So substitution, really, the idea is that you guys already know how to do this. If I say 2x is equal to question mark, if I told you that x is equal to 3, you guys will all know that you would sub that 3 in for that x. If x is equal to 3, you'd sub that in, so it'd be 2 times 3 is equal to question mark. You guys all should know how to sub that in like that. If instead of making it x is equal to 3, x is equal to 3y. Well, it's no different. If x is equal to 3y, you sub it in for that x, so it's now 2 times 3y. Not a huge deal. Well, what if instead of 3y, I said it's 3y plus 4? That's okay. You'd sub it in for this x still, so it'd be 2 multiplied by 3y plus 4 is equal to question mark. Doesn't matter what we put x equal to, you're just subbing it into where x is. Before I do anything else, and don't be scared to say it doesn't make sense, because maybe that wasn't a good explanation. I kind of made it up and did it on the fly. But does that make sense? Because if that makes sense, this substitution stuff shouldn't be too awfully bad. Parts about it is getting it to where you have one of those variables by themselves, so that is a little bit more difficult. I get that. But the concept of the substitution part, that step, that new step, hopefully is going to be good. Okay, so to actually get into this lesson, I broke this down into 4 steps. Now, again, it's a double-edged sword. I don't want it to seem too overwhelming and give you 55 steps, but I also don't want step 1 to be 4 paragraphs. So I apologize. Obviously, that's hyperbole. But I apologize if it seems like there's a lot of steps, but I really tried to break it down. So step 1, solve for x or y. It doesn't matter which variable, and it doesn't matter which equation. You do not need to solve both equations. I would tend to try to do it as much as I could where you do not have fractions. Now, I will say, obviously, sometimes step 1 is done for you. These first several that we do, step 1 is going to be done for us. Step 2, then you're going to substitute that solved equation into the other equation. Make sure you're using parentheses, and that's what we did in my example, where we took this equation and we plug it into the other equation. Step 3, solve for the remaining variable. You should only have one type of variable left. Now, the reason I said only one type of variable is it doesn't matter if it's x's or y's, but it should be x's and y's. Then the last thing, once you have that one variable, we have to plug that into either equation to solve for the other variable. So once we have our x or our y, to find the other one, we sub that back in. So if that's still a little bit confusing, once we start doing this, I think you'll kind of remember. So number 1, step 1, and again, I tried to break it down, and we're kind of starting slow, and we might skip around a little bit if we need to. 1, get those variables get one of the equations where one of the variables is by itself. Well, we already did that. Actually, both of the equations have a y by themselves, so that's even better. That's perfect. For the other one, now since both of them are quote-unquote solved equations that have a variable by themselves, it doesn't matter which one you sub in for the other one. So again, it's completely arbitrary. I'm going to take this one, and I'm going to sub it in for this y here. Use parentheses, but the thing is, a lot of students try to decide when they need them and when they don't need parentheses. They end up messing that up sometimes. I wouldn't worry about it. If I were you, I would always use parentheses. I do that for the most part. I negative 4x plus 11 is equal to the rest of the equation doesn't change at all. So this part, we didn't do anything with that part. Now, the punchline says solve for the remaining variable. Again, we should either only have x's or we should only have y's. If you have an x and a y, you did something wrong. Because we cannot solve if it's just an x and a y at this point. You need to get rid of, that's why you need to get rid of one of your variables so we can solve for the other one. So we got rid of our y's, now we can solve for x. So that's negative 4x plus equal to negative 2x plus 5. This part, so the substitution part's maybe new this year. Everything else, though, the solving part, you guys should be getting pretty decent. Several other ways you can start this one, but I'm going to add my 4x. 2x plus 5. Should have given myself room on this one. 5 is 6. Divide both sides by 3. I get my x value to be, not divide by 3, divide by 2 to get 3. So that x value 3. So the step that takes the longest is step 3 when we're solving. Maybe that's not the hardest step, kind of depends on who you are. It's easy, but we've done it a bunch. We've done a lot of solving. Don't forget that we're not done yet. That was step 3. We still have one more step. We need to plug that 3 back in to find our y. You always need an x and a y for these. My hint with this one is when you plug it in, it doesn't matter which equation you use. I would always use an equation that the variable is all by itself. So whatever equation you got the variable all by itself, that's what I would use. So either one of these will work fine. I apologize if you don't have a lot of room. So I'm going to use this first equation. Equal to negative 2 times 3 plus 5. Again, I always use parentheses. So that's equal to negative 2 times negative 1. The answer is 3, negative 1. If I were you, not a bad idea to put it as an ordered pair, but honestly, I don't care. As long as you label your x and your y, you don't have to put it in an ordered pair as far as I'm concerned. I kind of like to put it in an ordered pair just so you can see that it is the same thing. If we would solve by graphing and we would find where they intersect, that's the same answer we were getting. The same thing here. At least I'm not going to go to a ton of detail and a ton of time on this, but remember, you can check your work by plugging 3 and negative 1 in for your x and y in your first equation. Make sure it's equal. 1 is equal to negative 1. Then plug it into your equation and make sure it gives you 2 things that are equal. You can always plug your work in just to double check. If you guys aren't going to do that, that's fine. That's your prerogative. But if you're one of those students that barely passed last quarter, or if you didn't pass last quarter, so you need to figure something out to help yourself, that's something you can take. It takes extra time and extra work, but you don't want to fail this class just because you didn't want to work hard. Okay. I'm going to erase some of this just so I have some extra room. Again, I apologize that it's all crammed in there. I hope you guys have a little bit more room than me. So same thing with the next one. Again, step 1 is solve one of the equations for one of the variables. One of the equations is solved for y. Now, a lot of these equations are solved for y, but it could also be x. It doesn't matter what the equation is. We just use y to axis slope-intercept form. Right here. So I have negative 3x plus, now instead of that y, I'm taking that y out and I'm putting in x plus 2. To do that, it's equal to x plus 2. It's equal to that, or the exact equal. Equal to. Now we solve that. Parentheses, but I would definitely encourage you guys to still do so. X plus x is negative 2x. Subtract 2, negative 2x is equal to negative 8. Positive 4. But once we get x, now we have to plug that back in to find our y. Again, it doesn't matter which equation you use, but the easiest equation will always be, in my opinion, one that has a variable by itself. So I have y is equal to 4 plus 2. 4 plus 2 is just 6. 4, 6. And the last one. Now, the last one's actually a lot easier than a lot of people think. There's kind of 2 ways to look at this. But the easiest way for me is to realize, in these last 2, we worked really hard to finally get to where we had one of the variables. So we did all this work till we finally had the variable x is equal to 3. We did all this work over here to finally get x is equal to 4. 4 is because they're telling us the y is equal to 5. So part, we don't have to do because we already know y is equal to 5. So essentially, we are starting on number 3. We're starting at this step right here where we already know one of the variables. So if I know one of the variables is 5, to find the other variable, just plug that in. So we have 4x minus 6 times 5 is equal to negative 14. And again, a lot of students struggle with the normal substitution problem you guys have been doing for probably a couple of years now. If y is equal to 5, you just plug y in for that. So that's 4x minus 30 is equal to negative 14. 4x is equal to positive 16. Divided both sides by 4, x is equal to 4. Well, I got my x is equal to 4, but what about my y? They told you already your y is 5, so you already don't have to solve for that. So my ordered pair is 4, 5. Now, I know it looks like a hot spot because I didn't have a lot of room. I apologize for that. But keep in mind, again, it's going to get a little bit more difficult than this, but this is the bare basics. All these had one of your equations with one of your variables all by itself already. We'll get into a little bit more difficult than that. But we're just getting started here. Any questions? All right, go ahead and do number 4 and 5 on your own. I'll put the answers up in a second, and then we'll move to 6 and 7. All right, my 2 answers are up there. Check your work with these. The big common mistakes that I will point out. This step right here, make sure you distribute your 8. That step, you have 8 multiplied by x plus 2. Since you're plugging that, it's normally 8 times y. You sub in the x plus 2. Make sure you distribute. A lot of people put 8x plus 2, and they forget to take the 8 times the 2. The other one that a lot of people miss, number 5, that minus x, you still need that minus. So it's minus, and that's why I use parentheses. And that's one of the places a lot of students don't think they have to, and you really do. That minus in front of your x still stays there, so it's minus negative 9 plus 2y. So you have to distribute that minus, that negative sign. So it's positive 9 minus 2y. Are there any questions on these before we move on? Again, if you didn't have very much space, I apologize. I was trying to make this not be 4 pages like the last one. Trying to save the environment, doing my part. Okay, so moving on to the next ones, and I've got a couple things I'll say before we start this one. Number 6 and number 7 are a little bit about that in a second. But honestly, unless I tell you to use substitution for these, most of you guys, if you see one like this, you'll use elimination. Pretty nice. So normally speaking, again, there are some questions that occasionally I say you have to use substitution or you have to use graphing. But honestly, when I do that, it's because I'm trying to help you. Because I try to give you like the ones we just did. Number 4 and 5, those are usually say you set up more for substitution. So honestly, most of you guys will use elimination for these anyways. However, especially number 6, you could use substitution. And the reason I say that is because this x is not all by itself, but it's close. There's no number in front. So to get that x by itself, all I have to do is move the 3y to the other side. For this one, if I subtract the 3y, I'm definitely going to x is equal to 3y minus 7, or negative 7 minus 3y, doesn't matter the order. Now we have the x all by itself. So now is where we can use substitution. Now, when you use substitution on this step, make sure you don't sub it into the exact same equation. That happened where people solve this one for x, and then they take this and sub it in for this x, and they get everything to cancel, and they get really confused. Whatever equation you have to sub into the other equation. We just switch some things around. Plugged into that very first equation. With 3 times my x is negative 3y minus 7. Minus 5y is equal to negative 7. We solve this one for y. So again, this is certainly not easy. I would never say that. but we've done this a lot, so I'm hoping you're getting better and better at solving these equations. So that's negative 9y minus 21. Y is equal to negative 7. The negative 9 and the negative 5. Make sure you're not adding 5y like this. A lot of people are still going to do that. Negative 9 minus 5 is negative 4. I add 21 to both sides. I end up with negative 14y is equal to positive 14. On both sides by negative 14. I end up getting y is equal to 1. Once you have your y, just like we've done before, plug that back in and solve for your x. Now, here's the key I'm going to give you. The key I'm going to give you is I would plug it into your easiest equation. For the second one, I would plug it into your new one, because your new one, the x is all by itself, and so that's going to make it easier to solve for that x. Now, I used to tell students not to do that, because I used to say, well, you're going to plug it into the wrong equation, but here's the reason I switched that understanding or that thinking. If you mess this up, you're going to mess everything up anyways, so you might as well just plug it in there anyways. Because if you mess that up, that y is not going to be equal to 1, you're already going to miss points on that. 14 and negative 14. So plug that back into your x. Plug that back into your y. That's negative 3 times negative 1. Positive 3 minus 7. Positive 3 minus 7. And so I get negative 1. Sorry, negative 4, negative 1. If you want to leave your answers like this, that's what I would do. That way you don't mess anything else up. But I a lot of times write them as ordered figures. Purposes, you need to know how to put them as an ordered pair. But short answer purposes, I don't care how you leave it as long as you show me where your x and y are. On this one, I'm actually going to skip this one, number 7, because this is one that very much, honestly, I would use elimination. So technically, the way you would do this one, solve x or y, but the problem is there's not an x or y that's almost by itself like number 6. Number 6, this x is almost by itself. Well, number 7, none of those are like that. So if you try to solve this one for x, you're going to get decimals. This one for x is decimals. This one for y, you're going to get decimals. You have to solve this one for y, so that's kind of hard to figure out. It's possible. I honestly, if I probably tell you which one to solve for, I think that'd probably help. But again, I'm going to skip this one because honestly, I would use elimination for that one 100%. Elimination would be way easier for that. So I'm not going to go over, I'm not going to make one that's really hard and really confusing when you don't need that. So go ahead and do, out of these two, just go ahead and do number 8. I mean, technically you could do number 9 as well because this y is almost by itself. But go ahead and do number 8 for now. That'll save us a little bit of time so we can move on. And I will put up the answer here in a second. All right, my answer for number 8 is up there. Again, if you want to do number 9, it wouldn't be that bad. It's the same style where you get that 1. I would add 7x to both sides. You get the y by itself. So number 9 is not like number 7. But just for time purposes, we're going to go ahead and skip that. Not only that, but same thing. And this is what I was going to actually go over. To talk about this. I'm not going to go over this one. Again, technically speaking, yes, you could do this one as substitution. You could solve. I would probably get the first equation. I would divide everything by -2. Get the x by itself. But like I said, any normal person in their right mind would use elimination to solve this one. If you worked for NASA and you were super brilliant and you really like substitution, you'd still use elimination on this one. Okay. So last but not least, we're going to really quickly talk about special cases, and we already really kind of talked about this with graphing. So 3 different outcomes. The one outcome is where you only have one answer. That's what we've been doing. Every outcome we've had, we get one solution. That's the normal thing. However, there are 2 other solutions. I need to correct that. That's okay. and there is, not all real numbers, infinitely many solutions. I kind of gave you guys a speech about that earlier. Again, I'm not going to be finicky about it this year. Don't fail, though, because next year I think I'm going to be a little bit more harsh on that, especially once I fix my notes. But the good news is it's the exact same. Oh, maybe I didn't because, see, look at me. Look at me go. I didn't mess that up. Guess thought I made a mistake, didn't you? Sorry, this is from before. You should also read instructions. So before, when we had a problem like this, we have 2x plus 8 is equal to 2 times x plus 4. We would solve it. We get a is equal to 8. That is true, so it's all real numbers. So that's what we did before, when we land one variable. Or the other option, where you end up getting everything cancels out. That's false. So that's what we used to do. We do kind of the same thing, set it up differently, but the end is going to be identical to what we did before, except for, again, instead of saying all real numbers, we're going to make sure we put infinitely solution, or infinite solutions, or infinitely many solutions. But let's see what that's going to look like. This one in, just like we did before, I'm going to sub this x plus 3 for this y. So I negative 3x plus 3 times x plus 3 is equal to 4. So again, I just plug that x plus 3 in for that. And solve this like normal. I distribute that, so I get negative 3x plus 3x plus 9 is equal to 4. And combining like terms, again, this is nothing different. Negative 3x plus 3x combined to be 0x, which is just 0. They cancel. If you want to put 0x, you can. That means they cancel. This part's going to be a little bit different. Now my x is canceled, so all I'm left with is 9 is equal to 4. And now it looks very, very similar to what we had before, where all our variables cancel. That's the exact same concept. So now that our variables cancel, just like before, we ask ourselves, is 9 equal to 4? No, not at all. So this one's no solution. Now you can probably assume what the next one's going to be. So I plug my x in for this x here. So that's 2 times negative 2y plus 4 plus 4y is equal to 8. 2, so I have negative plus 8 plus 4y is equal to 8. Just like the last one. And this is where some people are going to miss this one because they're going to add 4y to both of these and they're going to end up getting 8y. No, they cancel. That's the whole idea. They're on the same side of that equal sign. So when we combine our like terms, negative 4 plus 4 is 0y. So we end up with 8 is equal to 8. Again, when all your variables cancel, ask yourself if it's true or false. This one is true. So since this one is true, it's not all real numbers. It's infinitely many solutions. And again, if you just want to put infinite sol, you can. Was this a class yesterday that I said when you put infinite sol like I did and circle it, kind of looks like a smiley face whistling? No? Is no one else getting that? All right, well, you guys should think outside the box a little bit more. Or whistle more. Any questions on that? Now, again, I understand number 11 and 12. They're a little bit different, but I can't stress enough that they're the same thing we've always done, where when all of our variables cancel, we know a red flag should go up. Okay. If you have any questions, obviously let me know.